So this next video is going to highlight the axis of symmetry of a parabola. In the other ones we did the work, and once we had the graph we could identify the axis of symmetry. But maybe you might have a problem that doesn't graph nicely. Now for now, the understanding of this is going to be purely formulaic, meaning this is a memorization thing. Now the friendly reminder of what this would look like is the drawing. So in the drawing area, let's sketch a coordinate plane. Yours needs to be a little neater than mine. And then we'll show a parabola going through here. And if I were to fold this parabola roughly along that line, this would be my axis of symmetry. So as a formula where these whole deals aren't equal to 0, you would find the axis of symmetry where x is equal to the negative value of b divided by 2 times a. And so we can label this in both locations. Now I know this is red, but I still want you to show this. X is negative b over 2a. So we've got it written twice now. The vertex and axis of symmetry. Now look at this problem. What I'm showing you this for, all broken out, is that this is going to be a multi-part problem that I'll then kind of break down a little bit more specifically. So your eventual goal for this type of problem is to have a graph with all the details in the earlier problems. This time, however, we will avoid building a table to make the graph. So this is a little different from what we did in the first video. For the value y equals negative 3x squared minus 6x plus 4, complete the following. And then you can read through all this and pause it, and we'll do this chunk by chunk. For y equals negative 3x squared minus 6x plus 4, we're going to write the equation of the axis of symmetry. So x is equal to, and here's what I'm going to encourage you to do. Try to keep this vertically. I think you have enough room. Rewrite the formula. That's one more time that you've practiced it. So just in this short video so far, you've already written the formula 3 times. So we'll take the value of b, but I'm going to write negative, and then in parentheses I'm going to write minus 6, because I know these follow the format of ax squared plus bx plus c. So that means that b is not 6, it's negative 6. So then I'll draw my fraction line, and that's going to be 2 times a, which is a negative 3. I didn't bother writing that in parentheses. Working down, maybe I run out of room. I'm going to have a positive 6 over a negative 6, and then lastly I'll simplify that to x is negative 1. Now if this is done on paper, keep that all vertical. Now let's move on. And I think this won't move with me. Oh, never mind, we're good. Find the coordinates of the vertex. So over here in red, I'm going to sketch the idea. Now maybe you realize that this opens downward, maybe you don't. But either way, I know that my vertex will occur where my graph is symmetric. So because of that, that means that I already know the x value. We just found out that it's negative 1. So that means I could fold this graph on itself and I would know that the axis of symmetry would be at negative 1. And that's why we get a negative 1 value for the first location of this vertex. So let's go ahead and let's rewrite the whole formula. Y is equal to negative 3x squared minus 6x plus 4. So where I'm pulling that from is the original equation. And if I know that the value of x is negative 1, then I can plug negative 1 in. Here maybe I will use multiple parentheses to make it stand out. Now I know that negative 1 squared is 1 times negative 3 is negative 3. I can make that neater, sorry. I know that negative 6 times the negative 1 is plus 6, plus 4. And then I'd just be like, well, 6 and 4 is 10, minus 3 is 7. Now the cool thing is, by doing that, I found the y coordinate that matches up when x is negative 1. So I should maybe make a little note of the vertex and say that the vertex is at -1, 7. Now here's the deal. If you're like totally just robotic about this, you won't be able to memorize how to do these for a test. You might be able to cram and keep it for a couple days, but think about, well, this is where x is -1. There's my symmetry. And graphically, if I were to draw these every single time, I could figure out what's going on. Now, identify the vertex as a maximum or a minimum. This is kind of straightforward. Whenever you have a negative value in front of x squared, whenever you have an a, that means that it's going to open downward. So downward. Now, I've already sketched it this way, but if I wasn't sure, then I think, well, okay, it opens downward, and that means that my vertex would be the highest point possible, so the vertex is a maximum. And then lastly, graph the function. So here, I'm going to make a graph, and then at -1, 7, I'm going to put a little point, and I'm going to sketch the graph of this. And when I say sketch, I really do mean sketch. And the reason I say sketch is because we aren't doing anything beyond the constraints of this problem. Is this accurate enough in my graph? Yeah, it looks like it. Is the vertex accurate enough? Yeah. Am I told to do anything with this graph? No. So I think that's fine. And maybe I just label that as -1, 7. Which is the graph of y plus 1 equals x plus 1 squared? So many different ways you could think about this. Let's go maybe a long route. Y plus 1 is x plus 1 squared. Now normally we're used to seeing these things in standard form, so let's get it to that point. I subtracted 1 from both sides, and then maybe I FOIL this out. So that then these cancel, and I have x squared plus 2x. Now first of all, does that mean that this opens upward or downward? Well, it opens upward. And because of that, I could immediately cross out b and cross out d. And the more capable you are with looking at this, you'd be like, well, no matter what I do here, I'd still have a positive value in front of x. So I'd eliminate those pretty quickly. Now the other deal, too, is you could just be like, well, it looks like this has a value of 1, 1, and then this does not. So let's say I plug 1 in here. 1 plus 1 is 2, squared is 4. And then 1 plus 1 over here would be 2, and it looks to me like 1, 1 would not be on my graph. So maybe I just use logic that way. But if I really wanted to be thorough, and keep in mind this isn't a standardized test, so I'm not limited by time, but this looks like at -1, -1, I have my vertex. And if I were to plug those values in, then -1 plus 1 would be 0. And then 0 squared would be 0 on the right side. And then -1 plus 1 over here would also be 0, and it kind of checks out. But yeah, I mean, there's all kinds of ways you could go about this problem. So you're going to see a wide range of types of problems, graphing quadratic functions, and even when they don't say to graph, keep in mind that graphing these is going to be your go-to to make things more clear and to put more meaning behind it. You know, if you just cut corners on this, it's not going to help you out. Wolfram Alpha is a quick graphing program. If you type these in, you could also type in words like maximum and minimum to check your work. And then you could even go as far as using GeoGebra to really manipulate and mess around with these. So this is the second of 2 videos for this section, and I hope that this intro goes well.